Hi guys, this is Shahab, your physics mentor and faculty at askIITians.com. Today we are going to study about pressure, but at 8th standard level. Okay, so we will see the importance of pressure, we will see the physical phenomena going around us to understand the pressure in detail. So without wasting any time, let's start the topic. Okay.
Okay guys, so let's have a look at the syllabus of 8th standard for physics. First chapter is force and pressure, second is chemical effects of electric current, third is light, and fourth is some natural phenomena, okay, lightning, thundering, and so on. Okay? And then we have chapter called friction. Then we have stars and solar system, and in the last we have sound. So this is the syllabus of physics for 8th standard. Okay, now we are going to study the topic pressure from the first chapter, which we called force and pressure. And this topic is really very important. It plays an important role in our day-to-day life. If we talk about its weightage, it's almost more or less 15%. In CBSE, according to school exams, and if we talk about Olympiad and other entrance examination, force and pressure carries a great amount of weightage because most of the numericals are based only on this chapter, force and pressure. Then we have few numericals in light, very few numericals in friction, but most of the numericals are based on this chapter. So this chapter is very important for us. Okay, so we will study and stick to the topic pressure. In this example particularly, what I am trying to tell you is that the force, the pressure, I mean if a lady is wearing a shoes with pencil heels and she stands on you, then she will hurt you more than an elephant would stand on you with one leg. Is this not shocking? The lady will hurt you to the same extent. In fact, she will hurt you more than the elephant if elephant stands on you with one leg. So what is it actually? What is it which actually decides how much we will be hurt? Look at this second example, guys. Look at this example. Here we have a balloon. You can see here we have a balloon. Now this balloon is being pressed against so many nails. So it's not getting burst. If I ask you, if there was only single nail, and you would press this balloon against that single nail, what would happen? The balloon will burst. Yes? And similarly, if you look, this is a physics professor. He's demonstrating in the classroom pressure. And to demonstrate pressure, he is performing this experiment and he's putting all his eggs in one basket. He's slipping over so many nails. Now you can see that he's not getting hurt. It's not hurting him too much. He's relatively at ease, no problem at all. So what is it which will decide that he will get hurt or not, or the balloon will burst or not? So it is pressure, and we will understand pressure in detail. Okay, so here is how we define pressure. You see, you have a nail and you hit this nail with a hammer. So this hammer is applying a force on it, and because of that force, it penetrates into the block. But if I ask you, if you turn the nail upside down like this, and you hit the hammer with the same effort, with the same force, what do you think? This time will it penetrate into the block or not? You will say, sir, maybe, may not be. So what is it actually? You see, in the first case, when the nail is like this, the pointy area is in contact with the wooden block. But when you keep it upside down, the flat area is in contact with the block. So first of all, you should understand that it is not force which will decide whether the nail will penetrate or will go into the block or not. It is something else. So if you look carefully, this pointy area in the first case, when the nail is like this pointy area, all the force F is concentrated only in this much pointy area, right? And when you take it upside down, the pressure is concentrated over a significant area. That means if the pressure is concentrated in a tiny area, if the force is concentrated, in a tiny area, it will affect more. And this thing we call pressure. So pressure is actually how much force is concentrated over an area. So if the force is concentrated over a tiny area, it will affect more. And mathematically, this ratio, force by area, is called pressure. So if you have a tiny pointy area is very, very less, the pressure will be very, very high. Okay? Okay. So the pressure tells us how much force is concentrated. If you look at the first example, when the pointy area, when this area, pointy area, was hitting the nail, the area in contact with the wooden block is very, very less, the pointy area. So the pressure definition, force by area, if the area is very small, the pressure is very huge. And that huge pressure actually causes the nail to penetrate into the block. But if you turn it upside down, the flat portion has a significant area, right? So if area increases, keeping the force same, right? Area increases, the pressure decreases. As you can see, pressure is inversely proportional to area. More is the area, less is the pressure. And less is the area, more is the pressure, right? Okay, one more important point, guys. Pressure is not exactly force by area. It's force by area, but this force should be perpendicular to the surface. This is the condition. The force should be perpendicular, then you can define the pressure. So this force should be perpendicular to the area. And this perpendicular force sometimes also called as thrust. So thrust is not an alien thing for you. It's simply a force which is acting perpendicularly. So you can define pressure as thrust by area, or you can say perpendicular force divided by area. Now let's talk about unit of pressure. If you see, pressure is written as force over area. The force has unit Newton and area has unit meter square. So Newton meter square is the unit of pressure, SI unit. And 1 Newton meter square is also called as 1 Pascal. Okay, so you can say Pascal is the unit of pressure, or Newton per meter square is the unit of pressure. So please keep in mind, less area, more pressure. More area, less pressure. So high pressure will damage you more. Less pressure will damage you less, or it may not damage you at all. Okay, so let's go back and see, let's explain those phenomena. Okay, so let's concentrate on the two examples we have seen. You can see that the balloon is pressed against so many nails. So I understand that all the nails have pointy area, but there are so many nails in contact with the balloon. So if you take the total area which is in contact with the balloon, is a significant area, right? Now, if area increases, area in contact increases, the pressure decreases, and that's how it will not damage the balloon, it will not burst the balloon. Similar is the case with the professor. Professor is lying over so many nails, so the nails in contact with the professor, if you take all the area, the pointy area, it contributes a significant amount of area. So it's a lot of area of the nails in contact with the professor. So area increases, pressure decreases, so it doesn't cause any problem. Okay guys, so this was all about pressure, how it affects our day-to-day life, and how much it is important. Okay, so I hope you enjoyed learning about pressure. Thank you so much.